Welcome everybody to my talk. So I'm actually like my final stage of PhD. So in few months I'll be a doctor. So I can get rid of this education or so. um, Firstly, thanks for the audience, like who actually voted for the talk, and also the Hack in the Box team for inviting me. Thank you so much. I was also here last year talking about LTE self-organizing networks, and it was well received. And then I see a lot of bugs being addressed in the standards, and also with the operators and even baseband vendors, like trying to fix these problems. So this year I'm actually trying to talk on 5G. So let's go a little bit into the future and then the kind of attacks that we expect in 5G, or we tried actually in our labs, and then that we think that might be a problem in 5G networks. Just to give an overview of what's coming up. So I try to give how 5G security looks and what kind of 5G security we can expect. And then directly move on to the vulnerabilities that we found in 5G protocols and the kind of impact it creates and how we fix them, talking to so many baseband vendors or GSMA or even 3GPP. Okay, so I don't really have to tell the kind of hype that 5G has created these days. Everybody is talking about it. I think it has the biggest hype in the whole like in this 2019, like in this 21st century. So basically, I believe that it's a technology that's for machines to communicate, not for humans. Like all these days, like we have been making phone calls, sending messages, and everything, like using 2G, 3G, or 4G. Like this was like quite convenient for us. Like we made so many calls, like this and that. But 5G is not about like making calls or like. I mean, there's no point of like developing a new technology and then just having it for your voice calls or something. So which we already do it these days. So like there are, I would say like there are three different kinds of people like who say we already have 5G, and somebody is in between like maybe or maybe not, and somebody is like no, we don't really have 5G. And so I fall into the third category. So we don't really have 5G now, or if you want to know the kind of like status of 5G networks today, there are certain countries like, for example, South Korea or some parts of Japan and some parts of Scandinavia that are trying to implement like or like do some testing on 5G networks. But basically, like there are like two types of 5G networks that could be established. The first one is like the non-standalone mode, where you have the 5G radio, which is like a pure 5G radio, which is completely different technology when you compare to 4G. And the core network is completely based on what is existing on 4G networks or LTE networks. Then the second one, there is standalone mode, which is just dedicated for 5G. So you have a new 5G core network, you have a new 5G radio network. So everything is kind of new, and everything is based on virtualization technology and all this stuff. So like new technology is being entered into the standalone mode. So now I think people are only able to witness the non-standalone mode. So it still takes a few years to actually get this implemented. So basically like 5G is, we have like so many applications like in the future, like for example, like smart cars or even critical infrastructure or even controlling remote devices, telemedicine or telemetry. It's like we have thousands of applications coming up, and like controlling or operating these devices from the mobile operator's infrastructure and having technologies like virtualization or even software-defined networking, network slicing, or having these kind of technologies implemented in the core network and trying to control all these applications. It's a huge interconnection of so many things, and that's what is 5G about. And I think we are driving in this direction. So maybe 5 years from now, or even it could take longer, depends on how quick the carriers are implementing. So there is like, we have a new kind of technology being implemented in the operator's core network. And it is like, we can easily expect that there could be more attacks or more new vulnerabilities that could happen in the future. So there's a lot of work which is coming up in 5G. That's what I wanted to say. If you look the kind of security requirements on 5G, they are really strict. They have like so many requirements because when you compare to LTE, which was proven to be like more secure compared to 3G or 2G. So obviously when you're designing a new technology, you have like more strict requirements trying to achieve for the future. So we have like new use cases. So this security requirements is built on three things. So the first thing is like new use cases. For example, like the broadband and the media we have, like all the data applications that we are using, which require high speed. Then we have smart driving, even automated applications. Like then we have critical infrastructure, for example, like public safety applications or government applications, or even controlling or city management, traffic control. Then we have like sensor devices that are, for example, in agriculture or monitoring buildings, surveillance. So all these applications like have their own application requirements and which will be controlled from the network side. Then we have the LTE security requirements in terms of over-the-air encryption or integrity protection of the messages, or not only the control messages, but also the data messages which are exchanged over the air. So LTE has like proven to be really secure in terms of encryption, integrity protection of data messages. Then we have, like I said, we have the new technologies like NFV, network function virtualization, then software-defined networking, or you could also like just put it like network slicing, where we are trying to bring the virtualization technology into network operators' infrastructure, which never happened before. And this could be something very interesting, where the network operator's hardware is actually shared with third-party applications. This could bring up more problems, actually. So and the way how operators manage this, control this, I think will define the kind of 5G security we will see in the future. So it could get worse, or it could get really best. It depends on how operators do implement this. I just try to put in a simple way like the kind of elements, the security or the kind of elements that we find in 5G network. So on the left side, like we have the cell infrastructure, like we are all aware of this, which has devices, then it has base stations. So there are like different type of base stations, like central, distributed, so we don't really want to get into that. So in terms of like mobile devices, like they are not anymore just smartphones, like there are different, like they could be also cars, they could be smart homes, they could be any kind of sensor devices. For example, maybe you must have heard narrowband IoT devices or machine type communication devices. So it's going to be more and more different variety of devices that are holding modems, 4G or 5G modems. Then we have different type of base stations, and the security model between them is actually defined by these parameters. Like there is authentication, which we call authentication and key agreement protocol in 3GPP terms. Then we have encryption of the data. Then we have integrity protection of data, and then signaling messages. And then we have like privacy, which is like trying to hide location of the user or location of the device, or even the identity of the device. For example, like IMSI and IMEI. Then we have resilience, which quite improved from 4G to 5G. So like what happens like if somebody tries to misuse certain type of messages, which are even, which could be even played without having any kind of authentication. Then we have like different device identifiers, like I said, IMSI, IMEI, or TIMSI. So this could be like protected. These are like really protected well in 5G. Or let's talk about like IMSI, which is the most attractive factor actually. So it's the permanent subscriber identity, and it's protected in 5G. There's a new mechanism called SUPI, so which is like trying to hide or use public key encryption to actually encrypt the IMSI and then send it over the air to the operator. So, but this is again an optional feature in 5G. So we really have to wait and see if operators do implement this, because it takes quite some time or like an effort to place a public key in your SIM card and then do this public key encryption. Then on the moving on the network side, like we are trying to bring the applications more onto the base station. So this actually increases speed. Then again, like how operators manage this is something really we have to wait and see. Then on the core network, like I said, we have different technologies like virtualization. For example, let's take a simple case where let's take any third-party application provider, for example, like Uber. So they get access, or for example, like here we see like thousands of different devices, and maybe operator could design 20 different slices, and each slice is dedicated for one type of application. Or let's say one slice is being dedicated for agriculture applications, because those sensor devices located there really require different kind of quality of service or different kind of battery monitoring techniques, or like it's completely different from traditional smartphones. So each slice will hold different kind of security features and even quality of service, or even any kind of parameters like that are responsible for security. On the other side, the internet, which is based on the diameter protocols, we're not going into that, but I think there's a talk on this one, so maybe you'll find more interesting features on this. Okay, so there are like a lot of elements which are involved in the whole 5G architecture, but I would be mostly talking on the over-there interface, which is between the phone and the base station, which has always been my interesting area. So we found some new problems there, and then let's try to see what they are. But before going that, let's see how security between this mobile device, it may not be a phone, but it could also be any kind of device which has a modem in it, and how the security has evolved between these two entities. In the beginning, like there was no mutual authentication, 2G was really bad. Then in 3G, there was a mutual authentication between phone and the base station. But although it did not eliminate the fact that rogue base stations can exist in mobile networks. Even today, even in 5G, it's possible to set up a rogue base station, but how successful would that be? It depends on some implementation flaws, and there are also some standard flaws which could be exploited. On 4G, there was also the same mutual authentication, which was taken from 3G, but slightly enhanced. Then there was additional integrity protection for signaling messages, trying to prevent man-in-the-middle attacks. So it was like quite successful in terms of encryption and integrity protection of these messages. But there were still many attacks which happened that could do location tracking, or even fraud attacks on voice over LT packets. There were a lot of attacks which happened on 4G for the last 5-6 years. Moving on to 5G, we have the similar kind of mutual authentication, but slightly enhanced. Then we have integrity protection for data messages, which is again an optional feature in 5G, because if you go back to 2017, there was one attack where web redirection attacks could happen when data is not integrity protected on LTE. So this was provided, but still again it's optional. So 5G actually brought up this feature of protecting IMSI, but it's still left optional. There are like several reasons for that. There could be government like regulation laws which don't allow or like hiding the IMSI on the air. So 5G is like super complicated in terms of like getting this. So many of the security features have been left optional. So it's again up to the baseband vendors or even operators like to get them in practice. So IMSI catches. So this is not a new name anymore. Like people are aware of it, and so many countries still use it. Now they have like 4G IMSI catchers which do directly attacks on the 4G interface. They don't really do the downgrade, but they can possibly do on the 4G interface. So if we look at these identities, which are like two most important parameters, or like information leaks, which somebody could actually get over their interface. Then on 2G, both could be acquired. Then on 3G, yes, also it's possible to acquire IMSI and IMEI. But on LTE, they try to protect one of the identifiers. So if you do not do any kind of authentication, you cannot get the IMEI of any device, even if you are operating a rogue base station. But in 2015, we were trying to play with some devices, so there was some kind of misimplementation by many of the baseband vendors. They could not implement what exactly was said in the standard. So we could still exploit or acquire the IMEI from devices even without having any kind of security protection. Then on 5G, both of these identities are concealed, so it's standard-wise, it's not possible to get IMSI and IMEI if correctly implemented on 5G networks. So we were trying to see, are there like any other possible ways that you could still identify devices on mobile networks or identify subscribers even. So on that, we were like trying to find different vulnerabilities or reading 4G protocols or new 5G protocols. So I will come back to that in a moment. So just looking at 5G security, obviously it has to be stronger than 4G. I hope it is, but we will have to really wait and see like what kind of attacks might happen. Then there are like similar security algorithms in terms of encryption and integrity protection. They are really doing good. So they are based on AES, and then they are also thinking about having 256-bit encryption algorithms. So, but this is still in discussion. So we really have to wait for the future. So some of the attacks which were actually fixed on LTE, for example, like there are downgrade attacks which could be done by just sending one simple message to the phone. Or there are even denial of service attacks just based on like sending a simple message and then the device stays in limited service mode for like until you restart the device. Or even location tracking where it's possible to directly obtain GPS coordinates from the phone without doing any kind of authentication. So these attacks were actually fixed for the last 3-4 years, and then they should not happen on 5G if they are correctly implemented. So the basic assumption is here is like if something is not detected on 4G, it's obviously copied to 5G. So if some attacks were not detected or like people missed it on 4G, so it means like because 5G is built mostly on the 4G protocols. There are like some enhancements, but mostly on the radio, then on the core network, but majority of the protocols, the way they operate, the state machines are similar. Maybe they really support different applications. For example, like V2V applications or V2X applications, they are supported in 5G. So this could be something again interesting. So if you are wondering like if there are any kind of fake base station attacks which already happened on 5G, maybe you could refer to this paper which exploits some authentication protocols in 5G networks. This was 1 year ago, so I just put it here for some information. Okay, so going to the new vulnerabilities on 5G networks. So there is something called capabilities in the mobile networks. So every device which has a modem has some capabilities. I'm not talking about the capabilities of the operating system like apps processor or the RAM or the screen size. So I'm not talking about this. I'm talking about the capabilities of the modem, which as a normal user we cannot see. There could be like 2 different type of capabilities each modem is holding. You could call them like core network capabilities. For example, like does the device support voice calls, or does this device support like data support or SMS support, or what kind of security algorithms it supports. So this is referred as like core network capabilities. Then there are like radio access capabilities. Just by the name we can say that this is something to do with the radio. For example, like what kind of frequency band it supports, what kind of like TX and RX parameters it supports, the physical layer parameters, or even the MAC layer parameters. So, or even does it support like the MIMO, like multi-input, multi-output technology on LTE, or even does it support carrier aggregation, or there is something also called category. Category is like every device has a category. For example, if you take iPhone X, it has a Cat 16. If you take Samsung Galaxy 4 from 2009 or something, it has like Cat 8. So the higher the technology, then the higher the category. Okay, so these are some of the capabilities, and then we were trying to exploit or see what can we get out of these capabilities. This is like a Wireshark trace, like where you have expanded version of capabilities. So different parameters, like for example, here if you see like this device actually supports, maybe this is a mobile phone actually, so it also supports 2G and 3G. So when it is actually communicating to the network, it would send its core network capabilities to the network, and then it would also indicate that it supports mobile station class mark 2, which means like it supports 2G technology, and then 3 also says that it supports like 3G technology. So it's like indicating what I support, and then based on that, I receive the service. Or if you look here, something called voice domain preference and UV usage setting, which says like, does the device require voice call support, or does it have the voice call support? Because then it should support like all the voice codecs, AMR codecs, and everything. If you take a USB data stick, it doesn't really do the voice calls. So it doesn't indicate this kind of capabilities. Some 5G specific capabilities, for example, like V2X connected cars. If you see something here like, so V2X PC5, it means that this device or this modem has the V2X capabilities, and then it can activate the V2X services if the network supports. Then there are other capabilities like cellular IoT specific. This came in the last releases of LTE. These are really IoT specific. So typical features that IoT modems require, for example, like keeping off for several days because they only transmit few bytes of data now and then. There are like different capabilities for each device. Then we have radio access capabilities, which mention here it says like UV category 4. Then there are other parameters like physical layer parameters, RF parameters, then measurement parameters like what kind of bands, what kind of measurements it can do, when can it exactly send this. So there are like thousands of parameters, like even more, and don't really have to know everything, but at least some of them that we tried. Okay, so when are these capabilities actually sent? So this is the basic registration procedure in the mobile network. So first it starts with the registration request where it's actually sending core network capabilities. Then it does the authentication and security. Then the core network says that get back the radio capabilities. So it would send a request to the capabilities. Then it would send the radio access capabilities. Then these radio access capabilities are actually stored on the core network. Because for the next time, maybe if the base station requires, the core network can actually send the capabilities instead of asking the mobile device. Then the over-the-air security establishes between the mobile device and the base station, then it's a successful registration. So if you look here, like basically the core network capabilities are sent in plain text because it's the first message. It always goes unencrypted. So a passive attacker sitting between the phone and the base station can actually get this, or somebody trying to operate a rogue base station can actually acquire these core network capabilities. If you go down, then there is something called radio access capabilities. If you look here, there is no security being set up, established between the mobile device and the base station. So there was already a security between the mobile device and the core network, but there is still not any kind of security established between mobile device and the base station. So somebody sitting between these two entities can actually access this radio access capabilities. So this was some of the fundamentals like that, how we started like doing this attack. So basically the fact is that these capabilities can be actually accessed by rogue base stations. They are sent in plain text over there. And then they were like they were like a mix of standard and implementation bugs that which we could exploit. So we tried like 3 different type of attacks. So we came up with this tool called MNMap. So traditionally we have Nmap, and then we tried to create something similar for mobile networks. Like then we call it like mobile Nmap. Then we do some bidding down attacks, like trying to bring the device down to 2G or even 3G, and then try to do some attacks there. Then we tried some different battery drain attacks on some of the latest NB IoT devices which are in the market. So I would talk about these 3 attacks. So for this, we had some experimental setup for this. So we tried to use different USRP. Traditionally, I'm used to use USRP, and then so we built a complete man-in-the-middle setup where we need to have 1 rogue base station and then 1 rogue mobile device. So this rogue base station is actually talking to the victim device, which is forwarding the traffic from the victim device to the phone, and from this acts as a legitimate phone to the legitimate network. So we are like acting as a man in the middle, routing the traffic from this victim device to the legitimate network. And then we are trying to do some modification attacks in between, which go undetected. So for the mobile network mapping, like I also tried to use so many devices. I would go with that very soon. Software, like there are some couple of open source softwares in the market, but we have to extensively, like heavily modify them to get this whole kind of setup working. Also, timing really matters, and then also the interference with operating your own base station and with a legitimate base station. You could also like avoid this with Faraday cages and stuff, because people have tried this before, but even though we had one, I didn't try to use it, but like in reality, like the setup doesn't look like this, because this rogue base station stays far away from this rogue UV, because like we don't want our own rogue mobile device trying to connect to our own rogue station. This could very easily happen. So we tried like attacks on so many mobile operators, like mostly focusing on USA and then Europe. So this is, the first one would be like the MN map. So we have the traditional nmap. What it's trying to do is like trying to find the live hosts on a network and then trying to expose the kind of operating system it has, the ports it has, and all this information. So we try to do similar things. So what we are trying is like, we are trying to identify the maker, the model, the operating system, then the applications, maybe the application version of that particular modem. So this is the kind of tree that I built. So first we try to identify who is the baseband maker of this modem, and then what kind of model it's running. So once we know that, we try to expand a little bit more, find if it's a cellular device or if it's a cellular IoT device. If it's a cellular, it could be a phone or a tablet, or it could be any other device, like some other device. So if it's a phone, it could be either Android or iOS. Like we could also take other categories, other operating systems, but I just keeping it simple. If it's an Android, then which kind of smartphone maker is it? If it's Samsung, Huawei, or HTC. Then if it's an iOS, like is it an iPhone or an iPad, or is it also possible to find out the kind of operating system version it's running? Then if it's like any kind of other device, then it could be a modem in a car, it could be a railway modem, it could be a router, USB dongle, or it's like, so we are trying to differentiate or just get this kind of differentiation or identify each device in its category based on the capabilities that we have. If it's a cellular IoT device, then we try to identify if it's a narrowband, because these are the only two categories that exist in the cellular standards. So it could be either of this. If it's this, it could. So basically, it's up to the user to have this kind of application. Like maybe they might implement narrowband IoT device for smart meters or smart grids, but this is what is recommended in the standard. So maybe they could use some LTE-M device for home automation devices. So yeah, we were like trying to extract all this information just based on acquiring the capabilities. So we try to set up a rogue base station, try to acquire capabilities from the device, and try to analyze them. So you might ask, like, okay, there are like capabilities which are defined by the standards and are implemented by the baseband vendors. Then how is this identification possible? Like, there are two main things which make this identification possible, because baseband vendors, like, they implement the capabilities differently. It's actually optional to implement some of the capabilities. So there will be differences between different basebands, which actually enabled us to identify them. Then the second one is each target application requires different set of different set of capabilities. For example, take an automated car, like say smart car. It should have this V2V capabilities enabled, or it's not a smart car. If we take a phone, it's obvious that you have this voice calling capabilities enabled. With that, we can actually say what kind of device it would be. Or if you take for like USB data sticks, like I said, there is only data support enabled. This could give some hint that, okay, this is a USB stick. So what we did, we tried to collect somewhere roughly around like 80 to 90 devices, and maybe 40 of them are like phones, and different phones from different manufacturers, different basebands, different versions. So whatever we see in the market, we try to just get them. So we have so many basebands. So mostly we try to focus on 4 different baseband manufacturers, not 4 but 5. With Qualcomm, then MediaTek, then Huawei, then Samsung, then Intel. So we try to acquire the capabilities of these devices. So apart from phones, we also have some routers, some laptops, some modems from the cars, some other devices from the military, whose capability is completely, or not completely, but at least 30 to 40% look different from the traditional or commercial devices which we see these days. And also some Quectel devices which are IoT related. So yeah, we try to collect the capabilities of these devices and then store them as files, and then all this like a PCAP files, and then we try to analyze the information in those capabilities. So first we try to find the baseband vendor, like who is this baseband guy. So if we look into the capabilities, like we found certain capabilities that actually differentiate the baseband vendors. There is something called EIA0. It's encryption. It's an integrity algorithm which is present in LTE, and it's 0, which means that all the keys are 0. So basically, they have this kind of security algorithm in LTE just to allow emergency calls, because like in emergency calls, you don't really want to do this encryption and security nonsense. So what we found was all of the basebands, they actually enabled this EIA0 by default, but only the Qualcomm baseband was actually disabling this. I don't know for what reason, but maybe they try to dynamically enable it. It's up to them. So again, it's an optional feature. So it's up to the baseband vendor either to enable or disable it. If you look, for example, like something called extended measurement capability. So this was actually only enabled in MediaTek's in chipsets. The rest of them actually disabled it. Okay, there are no reasons for this. Maybe there could be internal reasons why they implement this or why they don't implement this. Even if we ask them, like maybe they won't be willing to share why did they implement or why didn't they implement. So we just didn't bother to ask them like why do you have it or why do you not. So there are also different other capabilities, like maybe 6 other more. I just didn't want to show them, which maybe if these fail, you could use the other capabilities just to differentiate them. So the first level would be like trying to identify like who is the baseband. Then once we know the baseband, it's easy to tell which kind of LTE release it's using. If you just look Snapdragon, for example, like take Qualcomm, they are like Snapdragon 800 series. I think there are also even new ones these days, maybe somewhere around 900. Okay, so if you look into this, this is a big wiki, so Snapdragon 800 series, so it would just show you the kind of devices in the market that are actually using this chipset. So it's also available for even other chipsets, so like HiSilicon from Huawei, then MediaTek, then Exynos, and then there is also something from the Intel side. So basically, we try to look into this and then find out a list of devices that are actually using this particular chipset. We're still not done, like doing the conclusion, but we're just halfway. So we try to find the baseband model, then like the list of devices, then comes the little bit tricky thing, where you identify the device, the application of the device, or the right device and its application. So there are like differences which could be used to differentiate like cellular IoT devices, then cellular devices. So there are like certain timers which are only active for IoT devices. The rest of them, they are like disabled. So between phone and other devices, like there are some capabilities which are like voice or data, which is something present only for phones. Then for others, like it's not really enabled. If you look AMR codecs, this is only present for phones. It's not really enabled for other devices. Then sometimes like it makes it simple because like if it's a Huawei phone, it's obviously using a Huawei baseband. If it's a Samsung phone, it's using a Samsung baseband. If it's an Apple, then the only 2 options like Intel or Qualcomm. So it was difficult. This was the difficult one, trying to identify a difference between iOS and Android. There are certain features like MS assisted GPS or yeah, this is actually enabled only in Android and it was disabled in iOS devices. There are also a couple of, maybe one more extra parameter which is enabled in Android and then disabled in iOS. I don't know the reason, but I really didn't bother to ask why. But at least this was present in all like 80 devices that we tested. There could be some devices in the market which might differ, but I don't think that there would be like huge difference in that. So once we identify like this kind of information, it's really okay. Before that, like what can we do with this? But before that, like we had some certain issues. For example, the SIM card present in the device can actually control the capabilities or enabling or disabling the capabilities. For example, like you insert a SIM card from Asia, you might have the bands that are supported in Asia enabled. Maybe once you move to Europe, maybe the SIM card can actually control the enabling and disabling of this capability. So that's a bit tricky part to understand, like if these are the exact capabilities of the device. So it's not that we have to be an active attacker to actually get these capabilities. It's also sufficient that you can passively grab the capabilities over there and try to do this identification. Like I said, passive nmap also works because like a lot of people commented that you have to run an active base station to do this. It's not really necessary, because if you go back to the registration procedure, you saw that the capabilities are exchanged in plain text. So it's quite simple to get them in being a passive mode. So it's possible to link the IMSI to these capabilities and then associate or associate these fingerprints to different kinds of people. Once it's also possible to get the operating system version. I think I didn't put it, I disabled the slide. Maybe if you're interested, there's a big version of the paper coming up in the end of the slides. Maybe you can actually refer there. So it's also possible to launch some target specific attacks. Then the other nice thing we are doing is like we are trying to make this, so this whole thing is actually like automated. So we would like to share this tool. Then if somebody is interested, so if you want to play around with this, we would also like share the whole capabilities list we have. Just trying to hide the IMSI and IMEI devices or like identifiers from these traces and then share them. Okay, the second type of attacks that we tried on these capabilities was the bidding down. So normally, like if you're buying an LTE phone, so you obviously like expect that you get high speed, you get like 4G data, which is better than 2G and 3G, far better than 2G and 3G, and yeah. So the kind of bidding down we tried was, okay, this is the basic registration procedure. I'm bringing it back again. So if we see that. Capabilities are actually sent before actually setting up the security between the phone and the base station. So being a man in the middle, what we try to do is like we try to modify these capabilities and then forward it to the base station. And from there, these capabilities are sent to the core network and then they are stored there until you restart your device, which we rarely do, I guess. So if you try to modify the capabilities here, they go undetected. Like neither the base station nor the phone nor the core network can actually detect this. So what we are exactly trying to modify is so this is a trace from a field testing phone. If you look, one of the operator is trying to acquire the device capabilities before setting up the security mode command. I mean, this procedure doesn't have to be in this way. It could also be that you do the security mode command in the first place and then request the capabilities. This sequence is different in different networks, but majority of the networks that we saw, they try to bring the capabilities first and then do the security, which is leading the way for a man in the middle to do the modifications there. So what we are exactly trying to modify, we are trying to modify the category information. Then we are trying to modify carrier aggregation and MIMO technologies. So basically, we are trying to set the CAT to the lowest category as possible. So if you take an iPhone X device, like I said, it has like CAT 16. So if you set it to CAT 1, so it would receive the service that is a CAT 1 device is entitled to. You're trying to disable the carrier aggregation and MIMO. These are the two important technologies that are in LTE that are responsible for the high speed that we have today. If the device is not supporting this, then you are actually like losing the speed. We try to remove frequency bands, telling that it doesn't support certain LTE frequency bands. We also removed certain capabilities like SPS scheduling or ROCH compressions. So for voice over LTE, because like it's a HD voice, so you need some kind of compression technology supported in the modem. So if you are trying to disable that, it conveys to the network that this device doesn't support any voice over LTE features. Then you can also like remove the V2X capabilities that the device is supporting. So basically what happens in this case is like, when you modify these capabilities, like you're actually downgrading the service that this device should receive. So in some tests, like what we did, so without the man in the middle, like there was a normal speed of like 48 Mbps. I mean, if you're talking about like the theoretical speeds that are possible on LTE, like it's also possible to get 1 Gbps speed theoretically on an LTE network, but like in normal commercial, like day-to-day daily networks, like you just maybe 60 Mbps or 100 Mbps. It depends on the country also. So I was trying some attacks in Germany, and then the maximum we could get in peak hours was like 48 Mbps. With an iPhone 8. Then what we saw with the man in the middle was like, once we set the category to a different category, when we downgrade the category, the speed we receive is like 2 Mbps. And then when we try to call the device, instead of directly having the voice call on LTE itself, the device was being sent to 2G network to do the voice call and then return back to the LTE network. And then handovers like were actually made to 2G base stations or even 3G base stations, because that device was not supporting certain LTE frequencies which are present in the surrounding. I mean, you're actually trying to fake the capabilities, but the device actually supports it. In this case, the phone or the mobile device has nothing control, because it just follows what the base station is telling to do. So if it says like go to 2G network, even though it supports like LTE frequencies, it's just a slave which is trying to obey the master base station. So we also tried different basebands. Like for example, like we tried mostly on the Qualcomm baseband, because like they are all. So having this man in the middle setup was kind of very complicated, and it was like super unstable. So we always like depend on Qualcomm baseband, which we are like most favorable, and then they try to be more like have a stable setup at least, or they easily recognize the kind of software-defined radios we are using. So we are actually downgrading the device here. So basically, what I want to convey is like you're actually attaching a smartphone to the network like an IoT device. So basically, IoT device would go off, or it needs speeds like kbps. So this smartphone, once it's after this attack, it would receive the kind of same service that an IoT device is receiving. We tested these attacks on like so many networks. Like 22 out of like 32 networks are following the procedure that actually I showed here. So they do the capability transfer first and then do the security, which allows this man in the middle to succeed. And the capabilities were actually staying there at the core network. So every time we connect to the network or we send messages, we are still being under the influence of those modified capabilities. Unless you restart the device, your capabilities are not resent, and then in the absence of the attacker, I mean, and then you don't get back to the normal operation. So sometimes like it's also possible that there are like certain elite SIM cards. Like sometimes if you have an elite, you're working for the operator, so you get a different SIM card which obviously receives more speed, even though if you are in a big fest or like heavy crowd. But even that doesn't work, because radio is kind of the bottleneck for this high-speed services that we should receive on LTE. So if you are trying to kill this radio part or like modify the radio part, it doesn't matter like if you have an elite SIM card or you're the CEO of your carrier company, you will definitely lose the service or your service is downgraded. You might ask why the operators are actually doing this, or why the standard is actually mentioning that capabilities can be sent before security. So some reasons, for example, like to do better optimizations for better connectivity, that was the reason that we found in the standard. But like I said, 22 out of 32 networks are actually, or like there are like 10 other networks which are doing the opposite. So they are somehow exempted from this kind of attacks. When they are doing, I would say like, why not you also follow the same procedure and then try to avoid this attack in the first place. Then the third one was the battery drain attack. So there are like new type of devices like narrowband IoT devices. Their goal, the use of these devices is like once they try to send some data, once they register to the network, they try to send some data to the network, and then they can actually go off for a couple of days or even more, depending on the configuration. So they go off and then automatically turn on after maybe 1 week and then try to send data again. So this is some of the devices that we see in like smart meters or even agriculture sensors or something like this. So basically what we try to do is like, we try to modify the core network capabilities of this device, trying to say that this device doesn't support any kind of power saving mode capabilities, which means that the device cannot go off. So the network thinks that this is a normal device. This is not an IoT device. So it does not configure the device to actually go off once its job is done. So the device stays on and on for like several days. For example, at least like in our case, like it was like 13 days, the device was on, and then all its batteries actually drained. So we are actually talking about IoT in 5G. We are talking about IoT devices that would stay untouched for like 10 years of battery life. But it's with this kind of attack, like we can actually drain the battery within like maybe 5-6 days, and then the important thing here is like the attack is actually persistent. Because like once the modification is done, the attacker can go home and the attack stays active for like until the device is the battery is drained. And the network, not the device can actually recognize that a modification has actually happened. Okay, so coming to fixes, so we actually reported it to GSMA, and then they handled it like very smoothly, and then trying to get it to 3GPP and get a fix as early as possible. I think it took overall like 2 months to get the whole fix done. We also like have the CVD if you want to check it out, and then the actual fix was that these capabilities should be only sent to the network after establishing security. Like I said, many of the base stations, or like hundreds different base stations we tried, there is a configuration problem / implementation problem. We are not really sure because many of the operators like did not disclose this to us. So I think they would require some time to actually fix this problem in the base stations. Or it could also require some changes in the core network again, and I'm sure like this would take a lot of time to actually get it fixed. So coming to the the MN map is still possible even on 5G, even though if this fix is allowed, because like the first message to the network is actually sent in plain text. So somebody who is trying to acquire this core network capabilities can still do this nmap even on 5G networks. And we are still having a discussion with the 3GPP, like trying to get this fixed, but I think it will take surely some time because there are even other priorities, for example, more on the 5G use cases and everything, which will take some time. So yeah, so that was the talk, and then yeah, if you have any questions, I'm actually open, and thank you. Yeah.
I love telcos. I think telcos will never learn security, and it's fine. But it's also something bad for the users, which are us. So, speaking about that one, I got a couple of questions, and then I got another one because I would like to get 2 t-shirts for my friends, like you do. I'm kidding. First one is, I was kind of, well, not shocked. It's hard to get me shocked, but when you say that you scanned also on US operators, because they don't really appreciate such things. So, my curiosity is, have you informed them ahead of running the scans? And sub question is, were there any operators who noticed your scans or blind and anything?
No operators actually noticed this because like we try to keep the the other thing is like nobody is looking into this. even though they are, because like I was at Black Hat, and then most of the security with the US operators is on the core network, trying to see what's happening with the firewalls or with the web interfaces and everything. So nobody is actually looking into this part. So I think they are free, and then we have like the freedom to do it. And then as long as we don't get caught or like go into trouble.
You should ask two lawyers about this. I don't totally agree with you, but okay. I got a couple more, if I can. Still speaking about attack number one, when you say that with the mobile map, you couldn't, you show that you were able to fingerprint the devices, like let's say, and speaking about the cellulars. As far as I know, this depends if, for example, the MNO, he shields or it assigns a public IP address to the device. So don't you think, how has been the behavior of your scan? Because, for example, if you go to my country, we got 4 MNO, and 2 of them, they assign you a public IP address, the other one a private IP address, an internal one to the handset. But the third one is public, but it's not shared, is not meshed.
No, actually,
so how's been the behaviors?
No, we are not dealing with the IPs here. We are trying to operate a rogue base station, which would just trick the mobile device to send its capability. Okay. So we don't, we're not coming from the internet side, but we are actually going on the radio side.
Okay. My last one, speaking about attack number 2, I write so bad with my hands, I cannot even understand. Test with real networks for LTA downgrade. Yes. How has been the test on the real when you were trying attack number 2 in order to do downgrade on real operators, and did they spot anything again, or they were just keeping to watch at the logs of the IP and anything on the radio network?
Actually, it's very difficult to spot it, because like once we just try to operate this for like few minutes, or at least mostly we do it in the night. So when it's like when we have the complete freedom to do, or it's really difficult to spot it. Like it's unless like you have like highly specialized equipment, like the military grade equipment. It's really
that's
possible
why I'm asking,
to,
because speaking about the European ones, I'm a good friend to the CSO and CISO at KPN in Netherlands, and they do have a top security team. I think it's the only MNO in Europe that they do their job. So did you took the chance? I think I saw also Netherlands. Any feedbacks from there? Any alerts? Anything at all?
No, nothing like that.
Wow.
It's highly impossible to detect this one unless you're like, if you have some kind of like passive scanning device that's trying to monitor this. But most of the time we are not trying to, for example, like we spoof identities which are really like legitimate. If you're like spoofing some random identities, this might trigger an alarm. But if you're trying to be like very realistic, this goes like most of the time unnoticed. So, but I don't believe like somebody's scanning this traffic actually.
Well, I remember the research from Philippe Langlois with LTE back 5 years ago, I think in the box, and we have scanned all the world for LTE.
Yeah, there are certain boxes, but by the time you finish this analysis, we might have finished the attack and gone home actually. So it takes a bit of time to do this analysis, get some result. Okay, so this is not something expected. By the time like we are actually leaving the place.
Okay. Thank you.
So I have one question and one sort of word of caution. The question is, did you try different devices from different regions and different devices from different operators to see if the UE differences varied across those regions and operator companies?
Yeah, actually like bands is one of the main thing which varied a lot, but we are not majorly like depending on the bands, but certain capabilities like the measurement capabilities which we also use, they're also different when you're looking on European and then Asian phones. So we also try to grab some phones from Korea, Japan, and then try to see how different they are. So there are like a lot of differences, but we try to design the Nmap trying to eliminate those capabilities which might cause some disturbance in the mapping. So we try to eliminate most of them, and then, but you never know, like maybe in the future there might be a device which could again create a problem, something like this. So the nice thing would be like, we always try to update this with new devices, and then, so that's why like we are trying to keep it open so people can actually, if you have a new device, and maybe I might not be able to get that, so you upload the capability, and then it really helps to build the Nmap in a bigger way. So we really need this reference model as bigger as possible to get better detection. So.
And the word of caution is, I'm also the head of security for DevCon, and in a past life I used to work for Vodafone, and we routinely scan for this kind of behavior during DevCons and other events. It is absolutely possible to detect this in a targeted fashion. It's not possible to detect the tree in the forest, so if you're like in a city randomly doing stuff, you're pretty safe.
Yeah.
But once you've popped up on the radar and people know that you're doing stuff and they can target you, they absolutely can detect it. So be cautious.
Like, yeah, in certain areas, yes, it's possible, but we try to avoid those, and then I wouldn't like put something up in a DEFCON or like, yeah.
Okay, thank you very much. We are running a little bit short on time, but if we've got quite a few questions on Slido, which I don't think have been addressed. So just answer the top one.
No, this is possible. Yes, it will replace. Yeah. Then once again, if your phone is base station another. No, it's during the registration, the capabilities are transmitted, so they do not want to repeat the procedures again. So even if you're like handed over, the capabilities are transmitted from one base station to the other, instead of the device sending it again. Then with Huawei trying to model the Android OS, will this make Huawei to standard? I don't know like what OS they would come back. Maybe we have to check. We have to test the OS, and then we can, comment on that.
Okay, I think we'll stop there. Don't stand between everyone and lunch for any longer. So I think we have a clear winner for the questions there. So,
a clear monopoly.
Anyone want to claim ownership for the top question here? Is that yours?
I would like to ask an additional one. What was the blue one about
5G.
that you say no, it doesn't update anything when you move to the base station?
What if you roam the SIM card it roams to another country? Is still a no, or it updates something?
Yeah, when you're doing the registration again, yes, it would send it. Yeah.
Okay.
Who was it who asked this top question here? No one?
And the gift will go to me. Thank you very much.
Okay. Thank you very much.